looking at number 6. This is a rational function, and we did a quick review of these. This is only asking about one aspect. It's asking about where it's discontinuous. Let's just do a quick reminder of a rational function. First of all, just to answer the question here, we know that the function is going to have a vertical asymptote where the denominator is set equal to 0. So let's do x minus 3 equals 0, add 3 to both sides, and we get x equals 3 is a vertical asymptote for this function. We know, therefore, that it is going to be discontinuous at x equals 3. Okay, now that gives us our answer here. Now, why isn't x equals negative 4 an answer? Because if you remember about rational functions, actually, when you set the numerator equal to 0, what's going on there is you're going to get your x-intercept. And so actually we have an x-intercept here at negative 4. Because remember, your x-intercept occurs where y equals 0. And in this case, y will be equal to 0 where x plus 4 is equal to 0. Subtract 4 and subtract 4. X equals negative 4. So that gives us our x-intercept. Of course, our y-intercept occurs where x equals 0. So plug in 0 for both of those x's, and you get an intercept at negative 4/3 on the y-axis. That would be about just below 1, negative 1 1/3. We have not looked at the horizontal asymptote. All right, let's do that very quickly, and we'll have a better idea of this whole graph. Remember, our horizontal asymptote comes from looking at the degrees of the numerator versus the denominator. Since these have the same degree, then our horizontal asymptote is going to be coefficient of the numerator, lead coefficient over lead coefficient of the denominator. So you're actually going to get 1 over 1 equals 1. So our horizontal asymptote occurs at 1, vertical asymptote at x equals 3. You have your x-intercept at negative 4, your y-intercept at negative 4/3, which allows us just to sketch in this graph. And of course we have the other piece of the graph is going to go right here, again towards the asymptotes and diagonally across from the intersection of those two asymptotes. Okay, now I don't know if you really need to know all of that to answer this question, but you do need to be familiar with your vertical asymptotes, horizontal asymptotes, x-intercepts, and y-intercepts on your rational function. In this particular question, all you really needed to know was that the vertical asymptote comes from setting the denominator equal to 0, and therefore the function is discontinuous at x equals 3.